Yeah, good evening all, everyone. Am I audible?
Yes, Prashant.
Yeah, yes, Prashant, you are audible.
Okay. So, in the last session, we have completed till specification, right? AMBA protocol specification. So, anyone have doubts in AMBA protocol? Did you understood the main intention of AMBA protocol and how the signal working, the different signals between master and slave and the operating states and the waveforms, mainly the write transfer and read transfer with wait states and without wait state, and error I told you to check with the slave error signal, right? Failing with the write transfer and read transfer, and also write followed by reader. So have you gone through this up to here, everyone? Did you understood the specification? Have you tried with the designing using Verilog HDL? Anyone tried the finite state mission? Did anyone tried with the finite state mission? No. Okay. So today we will discuss on APB, FSM part and System Verilog program. And if you observe here, we have written the master bridge, right? Between AHB and APB, we just written the bridge. Actually, for bridge, there is a functionality. Okay, I will share you the theory part. Okay, how we are going to write the bridge, what is the final state mission for bridge, mainly final state mission will be there. If you understand that, mostly you can try to design the AHP to APB bridge. Okay, so today we will see on AHP to APB bridge, not in depth because actually it is in a UPM, but I will give you the insights into APB master and the most the design. Okay. So yeah, I can share you the code. You can check. Okay. You can try to understand because it is a very big code, nearly 495 lines out there. So I can give just to go through, try to understand the design just. Okay, no need to go in depth of a bridge. And coming to the APB slave using Verilog HDL, for I2C, is it clear, right, everyone? The system Verilog TB. Do you have any doubts in that in I2C?
Prashanti, I had a one doubt in in the questions. I had a one question like normally the signals which are output of DUT is the inputs to the test bench, right?
Mm-hmm.
Hello.
Yeah.
The question is, what are the inputs to the DUT? What are the outputs of the DUT? Those things are input to the DUT, right? I mean, input the test bench, right?
Whatever the outputs of DUT are there, those are the inputs to the test bench. No, nothing like that.
Yes.
How can we tell those will be the inputs? How
Okay,
can
I
we
have
tell?
one scenario is like, for example, we are having one receiver, like DUT receiver.
Mm.
From that one to next one, for example, DUT is a black box.
Mm.
How like can we test the test bench according to that? Either it is a receive from one end to one end if we are sending to the data. For example, here only in this example, we are sending APB to AHB to APB by using bridge. At that time, what are the signals it will take to how like it will test the DUT?
Here APB to AHB means first of all APB will be the master and AHB will be the slave. Whatever the slave signals are there here, if you observe, these signals we are here in the design. So whatever the AHB signals or whatever are there, the inputs and the outputs, those are main design here, AHB according to the FSM. Okay. So coming to the test bench, mostly the master signals, both master and slave, both we will generate. Not only the APB master signals, we will generate APB master as well as APB slave. AHB master, AHB slave, both it will be generated. Okay. We cannot tell like only master is transferring the data to the slave. Here both sides the operation will be happen, right? Both will work as a master and both will work as a slave. Okay. So we will consider master as a main sequencer and AHB master, APB master, AHB slave and APB slave. That is the main VIP. If you take in a complex way, that is totally dependent on how user going to design something. Okay, if you see in industry, every point to point we need to do the verification. If you see in industry, you can take both AHP as a master slave and APB as a master slave. But while we are learning at the learning stage, no need of taking AHP working as a master and slave and APB as a master and slave. You just consider AHP as a master and APB as a slave. Or you can consider APB as a master and AHP as a slave. One scenario is enough as in learning stage, but in industry every point to point we will check, right? So we will check at all scenarios. According to that we will develop. Okay, we cannot
I
say
mean, you
which
are saying like, you are saying like, for example, AHB is a master in DUT, and
one.
AHB we need to test as a test bench in our scenarios. If you are in
If
industry,
AHB is a DUT means, see, both may work as a DUT and both may work as a test bench also. Yeah, also, it totally depends on how we are writing. If you want to take AHB as a master, you can develop the master as a test bench also. Slave as a design. Okay, master will be the test bench and slave will be the design. Or else, if you want to take both the master and slave as a designs, then both the designs you can interconnect with the test bench and you can check the output. Output in the sense of whether handshake is happening or not between those write and read operations. Okay, it totally depends on how we are writing. Suppose if you don't have any designs, okay, you don't have any design, then you can create the universal component UVC. Just you can create uh, the UVC component and you can develop the test bench. Okay,
yeah, okay.
did you got my point?
Yeah, yes, got my point. Depending upon the things, depending upon scenarios,
Yes.
what we are facing, we need to develop the
Depending
thing.
on the availability, we can take. Okay. We don't have any fixed master and fixed slave. We can use anyone because all are bidirectional. We cannot tell every time the processor will be the master and some memory will be the slave. The transaction will be done from master to memory to processor also. Okay. Vice versa. It totally depends on specification.
Yeah, okay.
And
Thank you.
so coming to the our code APB. So here APB slave, we are going to design a slave dot v. Okay, slave is a finite state mission. Whatever the FSM diagram is there, we are considering the same FSM diagram and with the waveforms condition. Okay, so in the FSM, what are the states are there? Ideal, setup, and access phase. So in ideal phase, what signals need to be active? A low and a high, and which should be enable or disable. You already know the functionality. According to that, we are going to design the program. Okay, if you try before I'm explaining it, that will be good. Okay, you will get some more ideas how you can develop some functionality. Okay, no problem. See here, module APB slave output uh, pure data, read data. First output and P ready signals are taken, and inputs P address, P write data, P enable, P select, P write, P clock, P reset. So all signals will be declared with a P for APB. AHP means H like that. And bit present state and next state. Why? Because we are writing the FSM, so need to declare the present state and the next state, and memory also required. We need to create some size of memory. Based on memory size only, we can create the states. And type def. Normally in FSM, we use the parameter, right? A parameter ideal equal to some 0, 0, setup equal to 0, 1, access equal to 1, 0, wait state equal to 1, 1. But here we have used a type def data type, which is a user defined data type, and FSM state we have created for FSM, and always at the rate of posage clock negate reset. And if reset is active low, if reset is 0, present state equal to ideal, else next state, present state equal to next state. Always at the rate of case based on the present state. If present state is ideal, if P select is high, then next state equal to setup state, or else next state equal to ideal state only. And the present state is a setup state. If enable is high, then next state will be access state, because in access state only both setup and enable must be high, right? Otherwise, if enable is not high, P select next state will be in the setup phase only. Okay. And present state is access state. If P ready, okay, if P ready is high and select is 0, then next state will be the ideal state. You can check here. See, if P ready is high and there is a no transfer, the next state will be the ideal state. If P ready is high and there is a transfer, that select is high, then it will be in the same state until the count value will be 32-bit size here, and period equal to 0 in the access space. So next state equal to ideal, else next state equal to setup. If P ready is not high, that means it should be in a wait state until the transaction is completed. Okay, the next state will be the wait state. Okay, and present state is a wait state. If P ready is high, then next state will be the access, else next state will be the wait state. And default statement is necessary for every case statement or if else statement. So what happens if we don't mention the default statement? Can anyone tell me?
It infers a latch.
Now it infers the latch, the bad latch. Okay, so the default statement is necessary. And always at the rate of posage clock and negate reset. If reset is 0, pure data equal to 0 in the next two. If present state equal to access state, and if P write is high, then we are doing the write operation. Memory of P address equal to write data, else read data equal to memory of P address. Okay, so write in read operation. Initial begin P ready equal to 1. Forcibly at 300 time units, P ready equal to 0. Anyway, it is not synthesizable, but in simulation it will work. Release P ready. Okay, this is a simple APB design. Okay, so if you have some other idea, you can implement in same FSM only, you can use mostly. Okay, without FSM we don't have any transmitter receiver blocks. If you see in yacht, there we have the transmitter and receiver blocks, so we have designed by using frame format also we can design, but here by default we have the FSM. You can use the same FSM and you can design. Okay, so left, this is a Verilog. Okay, Verilog test bench. So, so how we have designed DUT and generated the clock and initialized with all values with the zeros, all inputs, and the reset task initially 0 and then 1, and the start method select is equal to 1, and in write task data input and address, and clock at the rate of posage clock, P enable equal to 0 and P write equal to high. P write equal to high means write operation. P write equal to 0 means read operation, right? And P write data equal to data input, P address equal to address input. So whatever the values. Here we are not generating direct values. And in the read task, so P write equal to 0 at this positive edge of the clock, P address equal to address input, P enable equal to 1. After some time, P enable equal to 0 after some clock. Okay. So from here, we are passing the values. First, we call the initialize task. So if you observe here, there is a initialize task and the reset task. So we have called the reset task and there is a start task. Okay, and write task. So in the write task, what we did here, uh, inputs, two input variables arguments we have considered. So passing the values, two arguments we are passing here, 12 comma 22. So what are the 12 comma 22 here? Data input and address input. The data input is a 12 and address is a 22. Like that, these scenarios we have taken 12 22, 13 23, 14 24, 15 25, 16 26. If you don't want to write in terms of task, you can directly write normally. Okay, you can mention, you can assign data in equal to something, addressing in equal to something, or else you can do the randomization. Okay, we have different methods. But if you write in terms of task, means the readability is good. Okay, so separate task for write, separate task for read, separate task for reset operation, so that we can read easily. Okay, the code, like good practice, that is a good practice. And then what argument we are passing for read, address, only address, no need to pass the data because data we get at the output side. Okay, so what is the address? 23, 23 address, 26, 24, 22, 25. So to that particular address we will get the data. Okay, so this is a Verilog part. See, the best practice is whenever, before I told you or not, I don't know. The best practice is whenever you are trying some SV program, if you want to implement a test bench in a system Verilog, first write the design properly, check the compilation errors, any syntax errors or any runtime errors, check with the design first, and try to write a simple Verilog program to the design because you are in practicing stage. Okay. Once you get the correct proper output with the Verilog test bench, then you can develop the system Verilog test bench. Okay. But don't jump directly to system Verilog test bench. Even if you know the design, just first check with the Verilog test bench. If you get the output properly, then you can go to the system Verilog test bench, because you will get the confidence. Okay. If you directly go with the system Verilog test benches, means there will be so many scenarios you won't get the output. Even if there are no errors, no design errors, no test bench errors, but still you won't get the error. There you will lose the confidence where the error is getting. Okay, you may not understand from design or test bench, but first if you try with the Verilog test bench, if it is work properly, means then you will get the confident, okay, the design is working properly and also getting the output correctly. Then you can develop the SV test bench. Same for UVM also. Don't directly write the UVM code for any design. Okay, first check with the test bench and then go with the UVM. Okay.
One question, Shanti. This is we have delay of two time unit here. So sometime it is written in the last, sometime it is written in the beginning, right? So what is the difference in that? No, no, not down, down, down. In the last you were showing.
Yeah, I have seen now. Yeah,
Yeah,
please
you
tell.
were showing that the screen. This one. So you see the initial begin, then dump file, then we start, then we are writing task and the read task. So there is a 2 nanosecond different this delay. So sometime I mean to say I'm confused. Sometime we write in the beginning, sometime we write in the end. So does it make any difference in terms of sending
Um,
the signal?
your
So
question
if
is sometimes you are writing begin end.
so no, 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 not like this. Initial begin, dump file, which is fine. Reset fine, initialize fine. Now
Uh,
the start, right? He start and the semicolon. Then after that, I'm giving the task and read. So
mm,
and in the end, I have given a delay of 2 nanosecond, correct?
mm, mm.
So
That
this
means,
2 nanosecond, if I put it in the
see,
beginning of
actually, all tasks will start at a time. Here, initialize task, everything will start at a time serially.
mm,
Okay. Here,
mm,
for write operation, for read operation, how the delay is taking means here we didn't mention any delay, but we have
mm,
mentioned at the rate of passage clock. So based
mm,
on the
mm,
delay, it will consider for every positive edge of the clock. Suppose here at the write operation, at the first positive edge of the clock, enable equal to 0, write equal to high, and data in some, input, address
mm,
some
mm,
input.
mm.
For next
Correct.
clock cycle, it will take enable equal to 0. So no need to mention proper delay here. We are
Mm,
considering with respect to the clock. And here,
correct.
why
Correct.
the delay in the sense, just even if you don't mention that, not a problem. But
Not a
for
problem.
read operation for these, and if you mention the some just a second delay means it will do the termination properly. You don't
Mm,
lose any data at this particular time. Okay.
mm, mm. Correct, correct. Okay, got it,
Did you
got it.
understand?
So, understood, understood. Okay, I understand this. Right, right, right. We are operation, then read operation. Then after that, 2 nanosecond, it will finish. Yeah, na? Mm,
Mm.
okay. Thank you.
So just run. So yeah, see here. Where is the read data? Okay, read data is here, and write data and address, p address, write signal is high. So here initially write is high, so it will do the write operation. So what is the write address? P address is same. You can take decimal format. Okay, see. So write address is a 16. At 16 we are writing C. If you observe here, uh, write is a 16 comma 26. 26 in the sense, C. 1626. See here, 1626, 1222. So 1222, 1323, 1323, 1424, 1424, 1525, 1626. So right operation is proper. Coming to the read. So here right, P right is low. P right is low means it will do the read operation. So at the read operation 23. See here. 23 means at this next coming negative edge of the clock 13. 26 means 16. 24 means 14. 22 means NAN. For 22 it should get 12 NAN. Okay. 20 in place of 22, suppose I am taking 23, not 23, 27. So 27 in the sense it will give X. So 27 also NAN. Okay, let me consider here 27. Hmm. Okay, 27 NAN. Okay, because 27 is not there in address side. At address side, we didn't consider 27, right? So that's why 27, it doesn't read the data. Remaining all is getting properly. Last one is not getting. Try to check in some other simulation tool. Okay. So NAN means it's not like not applicable. I think it's some unknown value. Okay, which is not used. Okay, so remaining all getting properly. So that is what Verilog test bench for APB design. Okay, so all the data is sending parallelly. So if you want to check with the system Verilog test bench, so everyone understood till now the Verilog program, Verilog design, and here also I did lot of changes with some other code logic and all. You can try, see here, suppose what happened if I mention in the access phase, here what I mention directly P ready. If P ready is high means then P select equal to low means then ideal state. Then what is the next state? You can try like this also. If P select is low and P ready is high, then what is the next state? Else if P select is high, enable is high, P ready is high, then what? How? Like that you can put some other some condition, different conditions, and try to check the logic. Okay, is it clear, everyone?
Yes, for me it's clear.
Okay, next coming to the test bench, system Verilog test bench. So generate block. Before generate block, we'll see transaction class. Okay. So transaction class. Can anyone tell me what is the difference between transaction class and interface? Wait, let me ask. Is there any verification, guys? Tamilarsan, Somshekar, Shivani, Omkar, Rahul, Divya. Can you explain SystemVerilog architecture? What are the blocks are there? SystemVerilog architecture. Hello.
SystemVerilog architecture is
Gen-
like first generator block.
uh, Generator driver. So driver to interface to DUT, DUT to monitor, then scoreboard.
Hmm.
So this will be
Okay.
in test under the environment.
Okay. So what is the top level of environment?
Test.
Okay. Top level of test.
Top only, ma'am.
Test based or test way. So where we get the packet level data and pin level data.
We will get top level data in the test and pin level data in the driver.
Okay. In the driver.
Yes, from the driver only pin to pin connection will send the transactions to the DUT.
Okay. What is the difference between packet level and the pin level?
Packet level means we will declare all the packages in one package.
Not package, packet.
Packet means sending a random number of transactions.
Okay. So what is mean by mailbox?
It's a way of communication between generator to driver or from monitor to scoreboard. It's like a communication between two blocks.
Which holds temporary data between the communication.
Mhm.
Like from generator to driver. So it holds the temporary data due to the because there may be communication like one generator can generate a high speed like and driver can operate at a low speed. So to not mismatch, like the mailbox helps to store the data temporarily.
Okay. So whatever the generator generating the number of transactions, without losing the transactions, without loss of data, while driver need to receive all the transactions one by one and it need to send to the DUT, right? So without loss of data, we are just putting all the data temporarily in the mailbox, which is like a FIFO. Okay. So through the mailbox, one by one transactions will be sent to the driver. The driver will get the transaction and it will send to the DUT one by one. So that's why mailbox is important, the communicator between the generator and the driver. Okay. Okay. So what is the difference between interface and virtual interface?
Where interface is static and virtual interface is a dynamic.
Okay. So why do we need to create a dynamic virtual interface?
Because we are declaring the interface is a static one, We are declaring it with interface name. It is a just like a static memory. So that's why if you want to access anything related to the signals from low level to high level, we need to declare it as virtual interface.
Okay. Shivasai, can you tell me why why do we use the logic data type in system Verilog? Shivasai.
Yes, ma'am. Because in logic, like basically, we don't know to like we can use like both procedural and continuous assignment, ma'am. If we declare logic instead of edge and wire. If we
Okay.
declare the edge, it will give a procedural assignment and wire as a continuous assignment to get we will use as a logic, ma'am.
Okay. So in Verilog HDL, we use both procedural and continuous assignment. There we have like reg and wire data type. So there will be a confusion like when to use
Between
the reg and when to use the wire. Sometimes there will be mismatch. Errors will
yes, ma'am.
be get because in terms of in-out signals, we use in-out signals also, right? So without
Yes, ma'am.
confusion and all, without complexity, because in system Verilog means we use lot of hundreds of signals. So to avoid that, we are simply using the logic data type in system Verilog in place of reg and a wire data type. Okay.
Yes, ma'am.
And can you tell me what is the difference between integer data type and int data type? Integer data type and int data type. Shivani, can you tell me? Omkar, Ramya, Divya, others, if anyone know.
Where int is a unsigned bit and integer is a signed bit.
No, both are signed only, right?
The int was in two state and integer was in four
No,
state.
signed and answer.
Okay. Okay. So int is a two state and integer generate four states. Okay. Okay, then I think everyone have the clarity on system Verilog concept, right? So everyone can understand the program. Okay, even if you don't have in-depth knowledge of randomization constraints and all, just try to understand overall. When you are practicing small topics like oops concepts and all, you will get more clarity because you before only you are knowing where to use all the concepts, right? So whenever you are learning individual concept, it is very easy to you. Okay. So first, while writing the system Verilog code, we need to start from the transaction class, either transaction class or interface. You can start. Okay. So first transaction class. So here what we need to do, we need to put all the transaction data. Transaction data means whatever the inputs, outputs, everything we need to mention here. Okay. So mostly inputs are randomizable. We will randomize the inputs. We don't randomize the output, right? So in system Verilog, all the inputs we need to declare as a rand data type. Okay. So the inputs all are declared with rand data type because we are using the randomize method in the generator. Okay. Whenever we use the randomize method, we need to declare the variables as a rand. Whatever the variables you don't declare as a rand, those will not do the randomization. Okay. So here p ready data, p or data, p read data and p ready both are outputs, so no need to declare as a rand. Okay. So what is mean by constraint? You already know in Verilog we don't have the controllability on the randomization. Okay, we don't have proper randomization there, and whatever the required values are needed, we don't generate properly. Okay, most of the values will be repeated values, so we don't get an accurate result there. But in system Verilog, we use the constraints. Constraints in the sense, whatever the particular values you want to generate according to the specification, you can generate the particular value. Okay, we will go very deep into the topics individually when we discuss the constraints topic. Okay, but as of now, I'm just discussing here whatever the example is there. Okay, see, one constraint is for what p address inside. So these are the syntaxes. 10 down to 20. So p address is actually 31 down to 0. The size is 31 down to 0. That means 2 power 32 number of values it will generate. But practically we don't understand. First of all, we don't understand 2 power 32 number of values, right? So we need just 10 to 20 number of values only. So like that we can generate. So we can use the constraint here 10 to 20. According to that, the random values will generate between 10 to 20 only. Okay. And next constraint is for write data. Write data inside 50 to 100. So for write data, I want to generate 50 to 100 only. So we can put that constraint. In constraints also we have a lot of variations like inline constraints, inside constraints, soft constraints. There are a lot of, but here we are using these constraints. Okay. And a function void display. So here we are displaying some class name. What is the class name? And write data, address, read data. So write operation. So whatever the data you want to print, you can write the here. So using function void. Next, generator class. Okay, generator means first block, the generator is nothing but it generates the random values for all the input values and send to the mailbox. That is the generator, right? See, class, generator, rand, transaction, tr. What is the tr? Tr is the object. Okay, in the generator class we have created one object tr. We didn't create it here, we just declare the instance here, just declaration. Okay, so if you see in 11th line, tr equal to new. Okay, tr equal to new means there we have created by using the new method. Wherever we use the new method, that is a creating in the system Verilog. Okay, so tr equal to new means creating the transaction object. Why we have created the object here? Because the transaction data here, transaction class. Okay, so if you want to access all the data in the transaction class, we need to create a object. Through the object we can access all this data. Okay, so that's why tr is a object, or we can call as an instance. Okay, and mailbox gen2 drive. So generator to driver, we are using one mailbox, right, between. So that mailbox name we have taken as a gen2 drive mailbox. That is how we can create the mailbox. And function new generator to driver. Function new means here it is a constructor. We call it as a constructor. That is nothing but creating the class. Okay, we create the class. In system Verilog like this we will create. But if you go to UVM, there we use some utils, macros, some factory registration concepts, all these things we use. Okay, but here we use simply function new constructor. And within here mailbox gen to drive. So why we use the mailbox gen to drive? Because for generator block only one connection is there. To the generator we don't have any other connection, so only mailbox connection. But if you see driver, we have mailbox connection and also interface connection, right? Two connections. So that's why in driver we will put two. If you observe here, one is a virtual interface connection and mailbox connection. But in generator, only one mailbox is enough. And this dot gen, already this keyword, why do we use? And task, in the main task, what we have written, repeat 10 number of times. TR equal to new, creating the transaction class, transaction object. TR dot randomize. So here we have used the randomize method. TR dot randomize. That means what? Whatever the variables are there in the transaction class, even if there are 100 number of variables, suppose here 100 number of variables are there. By using simple one object TR dot, we can access all 100 of variables. Okay. But if you see in Verilog, if you want to do randomization for 100 variables, you need to put p address equal to $random, p write equal to $random, p select equal $random, p enable equal to $random. Like that 100 variables, you need to mention $random, $random. But here by using simple object, we can access all the variables. That is the main advantage of dynamic programming. Okay, class based verification means it's a dynamic in nature. Okay, so after randomizing, so here tr.randomize means all the data will be randomized, all the inputs. Okay, after randomizing, what we need to do, we need to send to the mailbox, right? So gen2 drive dot put of tr. In mailbox concept, we will have some methods, okay, to use the functionality. So here put method means sending the generated data to the mailbox, okay, by using the put method. So in the driver, we will get the data from the mailbox, right? So there we use the get method, put method, get method. Remember everyone, okay? I think we already covered these concepts, right, for verification batch. So gen2 drive dot put of tr, and then tr dot display of generator. So what is the tr dot display? Already transaction class, we have created this function void display, right? And passing the string name here, string class name. So what is the name passing here? Generator. If you are writing in the driver, you can pass driver name, or monitor means monitor name, like that. So tr dot display of generator, and dollar display gen2 drive dot num. Just the num means how many number of mailboxes, that method. Okay, so this is the generator. In the generator block, we use like this. Okay, in SystemVerilog, we can create the n number of test benches also. N number of test benches is nothing but here we have taken one constraint, right? So these constraints you can mention, like in a test bench 1, you have taken this constraint. In test bench 2, second scenario, not test bench, test case. Okay, number of test cases. Test cases in the sense n number of scenarios. In test case one scenario, in test case another scenario, like that you can mention. In UVM, I will show you clearly, but in SystemVerilog, you can simply take like this. Okay, and so generator is completed, and then driver. So in the driver, what is the main task of driver? Sending the randomized data to the DUT. Okay, so how we are sending here? So generator to mailbox, and here we use the get method. By using the get method, we will get the data to the driver, and the driver will send to the DUT via interface, and we also create the virtual interface here. Okay, so driver have the two connections. One is mailbox connection, one is the interface creation connection. As we don't use this physical interface, as it is a classic in static in nature, we use the dynamic interface, I mean virtual interface. Okay, so how we will create that thing, see here. And also we need to mention same path. So whatever the transaction signals are there, whatever the DUT signals are there, we need to access all the DUT signals using virtual interface only. Okay, now see how we will write the path. Before that, we see the interface .sv. See here, interface. In interface, name of the interface is APB int f input logic clock reset. So we will mention the clock reset here, and all the input and output variables we will declare with the logic. Okay, most of you will confuse you want to put the logic data type in interface or in transaction class. You need to put rand in interface or in transaction class, like that the confusion will be there. Just avoid that. Interface means connecting the DUT with the test bench. While connecting with the DUT with the test bench means in Verilog, you need to remember reg wire. So just replace that thing with the logic here. Okay. Transaction means the randomized data. The input data we are putting there. All the we are declaring there. So you just need to randomize the transaction data, right? That's why you need to put the ran. It's a data type and variable. Okay. So in interface, just we will put the logic and variable. Okay. So next, clocking block. You know the clocking block. I no need to explain, because clocking block is used for synchronization purpose between the driver to DUT and DUT to the monitor. Okay. So here in driver, why all the inputs or outputs and outputs or inputs means, because from the driver it is sending to the DUT. So for the driver, those are working as output, and for the DUT, those are inputs. Okay, that's why. But for monitor, all the data is getting from the DUT, right? Here is the monitor. So whatever the operation is completed from the DUT, whatever the inputs or outputs, everything we will take into the monitor, and that will be sent to the scoreboard, and we will describe in the description, I mean at the transcript. Okay, we will write the data, right? So here all the data will work as a inputs to the monitor. So in the monitor we will declare as a inputs for all the variables. Okay, so that is the clocking block, and mode port is for port declaration. So whatever we have declared already in the clocking block, same we need to declare here. Okay, so in place of that, directly we are putting the clocking block CB. As we are not mentioning here the input clock and reset, we can put the input clock reset. Okay, that is enough. And mode put monitor. So here now we are accessing these DUT signals through interface. These are nothing but DUT signals now. Okay. So whatever the transaction data we are randomized, that data we need to send these to these signals only. Okay, in the interface block. Okay, in the clocking block signals. Okay. So in the driver, if you observe here, first line, there is a macro. It defined in the sense macro. Okay. So what is the path here? Why we write the macro here means see. The macro name is DRIVIF. DRIVIF. So if you observe here in the 16th line, there is a DRIF macro. 17th line, there is a DRIVF if macro. So these are the macro. That means the path we are directly, you can put this path also, but without putting that, we are just defining one macro, and through that macro we are accessing here. Okay. So what is this actual path? APB VIF. APB VIF means it's a virtual interface. See here in the third line, virtual APB int F. APB int F is the name of the normal interface. Okay. So how do we create the virtual interface? So virtual APB intf normal interface, APB VIF is the virtual interface. Okay. So the connection is APB VIF dot driver is the name of the mode port dot driver CB. Okay, see here. Mode port name is a driver dot driver CB. Okay. So through this path, that is how we are mentioning the path here. So to access all these internal variables, we are setting that path like that. Okay. So now simply how we have written DRIV, DRIV if dot p write. That means driv if is already this path. Okay, clocking block dot these signals we are accessing. Okay, so that's why we mentioned the path here, like that p write, p select, p address, p write data, p enable, everything we will access in the same format. Okay, so don't confuse. Coming to the class driver, second line, it's a class driver, virtual interface we have created, mailbox also created, transaction class tr also created because we need to access the transaction data, right? So tr. And here creating the class. What are the connections for the driver? As I said, there is a virtual interface connection, which is an interface, and mailbox connection. So two connections we have written here. And now task reset. As we written in the Verilog, the task, reset task, initialize task, start task, like that. In driver also we write. Okay, but it's a bit complex. So task reset, wait until APB VIF dot reset is high, low. Okay, low means because it's an active low, right? That's why it's 0. That means all will go to the reset state, zeros. All will go to reset state. Once it is high, APB VIF dot reset is high, then reset ended. So while accessing the signals also see APB dot VIF. That means through the virtual interface we are accessing the signals. In SystemVerilog we need to follow that thing. Through the objects only we can access. Okay. Normally in Verilog whatever we are putting reset equal to 0, clock equal to 0 directly we can't put. Okay. So next task drive repeat of 5 times. Gen2 drive dot get of tr. In the generator what we did put. So put into the mailbox. But in the driver get the data from the mailbox. Okay. So it is calling the write task and read task. Okay. So what is there in the write task? We are sending the data to the DUT. So DUT means this macro. This macro in the sense we already set the path, right? So that macro dot p enable equal to 0, p write equal to 1, p address equal to tr dot p address. What is the tr dot p address? Transaction data. We are sending the transaction data to the DUT data via interface. Okay. So p write data equal to write data. And next positive edge of the clock again enable equal to 1, write equal to 1, write data equal to some p write address and write data. Okay. So that is the write task and read task. For read task we will send only address, not read data. See, we are getting the read data from DUT to transaction class. Okay. And in the task main we are calling the drive. So if you have any confusion, just to check once, you will get the clarity. If you have any doubts till now, just let me know.
Ma'am, can I know what is the difference between interface inside the interface means the signals which we declared as well as the signals which we declared inside the transaction?
Interface signals which we declared in the transaction.
Yeah. What is the difference between the signals which we I mean both in transaction as well as in interface signals are same.
Same.
Then why we want interface and transaction? We can have one thing means enough, right?
That's what I am telling you. If it is a Verilog means you can put directly address equal to address, write data equal to write data, enable equal to enable, read data equal to read data. But here If you put both same, what happened? Where you are doing the randomizing? We are randomizing the data from transaction class only, right? In the transaction class only, we have the randomized data. That randomized data you are sending to DUT. Where we have the DUT? Through the interface, we are connecting to the DUT. So directly how you will send? Did you got my point?
Yeah, ma'am. Yes, got a
This
clarity.
is
Thank you.
what the path. So here we have the transaction data. The transaction data is randomized in the generator. Okay. Here DUT is there. DUT is connected via interface, that to virtual interface. Okay. So directly how you will send like a Verilog. In Verilog means directly we can connect address equal to address, write data equal to write data like that. But here it is not possible. Okay. Any other doubts? Others? Any other doubts?
Ma'am, here I have one more doubt. You are saying like write and read transactions, right? Whenever read is happening, at that time period needs to be high, right?
If period is low means it's a wait state. Period is high means then only we can read the data. Okay.
Yeah, it's
Not
ma'am.
only read, write also. For write also we will check period. Okay. Any other doubts? Okay. So monitor. Monitor in the sense same monitor also same like a driver only. We will write all the things. But see reverse. For driver, what we did, whatever the path we mentioned here, path will be the left side and T or transaction data is right side, because transaction data we are sending to the DUT. But here from DUT we are getting the data and sending to the transaction, right? So here whatever the interface data is there, that data we are sending to the transaction data. So here interface equal to transaction. Here at the receiving side, transaction equal to interface. Okay. So same we have did here. Okay. Right side is the interface data, left side is the transaction data. And then we are putting the data into the transaction class. Okay. Monitor to scoreboard dot put of TR. Okay. And in the scoreboard, same. In the scoreboard, actually, we will write the logic to check the reference bold and reference value as we written in the I2C. But here I didn't write. You can write. You can write and check. Okay. In the scoreboard, we will create the memory, and here we are getting the data monitor to scoreboard of TR and displaying the statement. Okay. So whatever the generator, driver, monitor, scoreboard is there, all we will run in the environment. Okay, generator, driver, monitor here. Constructor we are creating, and the pre-test, test, run. We will run call all the tasks here. Okay, in the environment, and in the tester we will call the environment task. Whatever the run task is there, that one we will call in the test. In top level, test bench.sv, header.sv. In header.sv, we included all interface.sv, APB slave, transaction, because if you see in environment, we need to include the low level components. Okay, here we didn't include it. Okay, all components I have included here itself, or else in the environment you can include generator, driver, monitor, scoreboard. In test you can include environment and virtual interface, and in top level test bench you can include a test like that. Okay, there are a lot of ways. While you are practicing you will get these things, and this is the main test bench top level. Okay, here the APB interf virtual normal interface, and the test is interfacing on top. Okay, so this is the SystemVerilog test bench. You can try your own code. Okay, don't copy, and just try your own logic. Okay. So yeah, check the output. Open waveform. Others, do you have any doubts? Okay, check the output here. Write data, address 1166, 1790, 1580, 1472, 1897. So 1790 correct. Address 20 is not there, so NAN. 1472 is correct. 1790 is correct. Okay, so check both. Try to understand the code. If you have any doubts, let me know. Okay. Clear, everyone? Is there any doubts? Divya, Omkar, Rahul, Shivasai, Shivani, Tamilarsan, Teja, Soma, Varun Joshi, Surya Kumari, Vinay Kumar, and
No,
remaining.
Prashanti, sorry, no doubt from my side. Just only one question. When you were checking those waveforms, you were selecting the get signals. So we see the DUT also. We see if you get signals, this one. If you
Mm,
click on the get signals, right here in the left side.
mm,
So you see we see the top bench also. We see the interface also, DUT also. So
mm.
usually we select the top one, right? TB top.
Yeah, we can select. Here there are only two signals, right? That's why I have
Uh,
selected DUT signals.
okay. So which one we usually select, DUT
In
or interface?
interface signals, interface any signals are same, because here
Hmm.
DUT signal means driver to driver to DUT connection we will check. Interface signals means after getting to monitor we can check test bench top level means like monitor means receiving the data from DUT, right? Those data we
Hmm.
can check. Hmm.
Hmm.
DUT means until driver.
Correct. Okay, got it. Thank you.
Okay.
Ma'am, can you explain once again that you are in the diagram notepad you were showing, right? How like we are sending the things from monitor to diver, I mean, monitor to from DUT to monitor here. Can you repeat that point? How like what you explained for monitor thing?
DUT to monitor means this is the interface data, right? Interface INT. Interface to transaction class I mentioned. Wait, I will write here. See, normally driver to DUT means driver side what we will have transaction data we have. So transaction data is equal to where we are sending interface data. So interface dot data. Driver to DUT means, but DUT to monitor means what? DUT side we have the interface data. Interface data is sending to where we are sending transaction data. This is what I mentioned. Wait. Okay, here your data. Okay, so here driver to DUT means transaction data we are sending to the DUT data. DUT to monitor means interface data we are sending to the transaction data. That means DUT data to transaction data. That is what. So here interface means what? The path already mentioned here. The path whatever we have taken. So this is the path, right? So this path we just take as a macro driv if. So that's why we kept here driv if. Okay.
Yeah. Okay, ma'am. Thank you. Yeah, got it.
Okay then. Thank you all. Bye.
Ma'am, can you please share this session?
Okay. Okay then. Thank you all. If you have any doubts, please let me know. Okay. In the next session, we will discuss on AHB. AHB is somewhat complex. If you want to gather any information, just go through some theory topic. I will share you the some sessions also. Okay. Meanwhile, you can go through the session so that you will get some doubts in the next session. Okay.
Okay, ma'am.
Okay then. Bye.